Time for practice test. Time for practice test. Hello, Marauders. Mr. Newell here. So today we got the practice test. So we'll guide you through this. And remember the goal of the first ones, simplify the days. You're trying to turn these complicated things into something simpler. And one of the tricks is to try to break this down. And we've got these rules. Don't forget these ones in here. Pythagorean relations. Maybe you can get one of these. You could use double angles. We didn't get into this. If we were in class, we would have also used power reducing and we would have used half angles. But because of, we're doing this at home, we don't want to get overwhelmed. And there's also these, sum and difference, which we found in section 2. This would have been section 4 that everybody skips every year. But most importantly, there's always these rules, like sine upside down, cosecant, or cosine becomes secant, or the other way around. Remember, sine over cosine could be tangent, cosine over sine, cotangent. So here's what we're going to do. Let's see if we can break these down into something simpler. I'm thinking, is this actually the same as something else? And there's several ways to do this. Some people might have said, hey, I could call this tangent right now and make that cotangent. But then, maybe that's not one of the choices. I'm going to have some multiple choices. But here's another strategy. I want to get these together. So what if I did common denominator? I'll give them all parentheses. So, because at first I was thinking, well, if I make him tangent x plus cotangent of x, hey, that works. And maybe that was the answer. And there'll be multiple choice, but maybe this wasn't one of the choices, but this is true. This is just the same as this. But the answer is even a little bit shorter than this. Maybe that's not a choice. How about this? Let's do common denominator and put these together. What if I said, hey, you got a sine? I don't have a sine. Remember we did these a long time ago? I'll give you a sine, and I'll give you, a sine. It's not writing very well. I need a new pen. Okay, we'll try that again. I will give you sine of x. This says sine of x. Okay, and this one wants a cosine, so I'll give him cosine x, cosine x. Now we've got the same bottoms. So let's say the bottom is sine x, cosine x. Okay, but what do we have on top? We have sine times sine. Sine times sine is sine squared. And here I have cosine times cosine. That's cosine squared x. And I'm like, I go, wait a minute. I recognize that. I've been seeing that a lot. I can kind of go, wait, sine squared plus cosine squared is just a 1. So I'll turn the top into a 1. And I've got this on the bottom, sine x, cosine x. Sometimes people don't put parentheses, but it just means multiply, but you can if you want. And then you go, okay, maybe I'll look for that answer. But maybe that's not one of the choices. Then you could kind of go, wait, if sine's on the bottom and cosine's on the bottom, we could actually move these to the top and call this sine on the top is cosecant. Cosine on the top would be secant. And this would be my answer. So there's multiple things you can break it down into, but there's one of the possibilities. Okay, for the next one, what should I do here? Once again, one of the best strategies is just using these guys up in here. What if I said, cosecant, I can write that as 1 over sine. I'll just change him. And then why did I do that? Because wait, sine over sine, that's the same thing. That would just cancel out to a 1. Same here. Let's see, we've got cosecant, cosine. Okay, well, cosecant, let's change him to 1 over sine. Now I got cosine over sine. Cosine over sine is also cotangent. And that's my answer. So this mess is the same as this. Okay, and one left. Your strategies can always change. So there could be other ways to do this. Let's see, what can I do here? I'm kind of like, wait, tangent, cotangent, aren't these kind of opposites? What if I took cotangent and rewrote it as 1 over tangent? Just change that to 1 over tangent. Now I got tangent of x times 1 over tangent of x. There's no add. And then these could cancel. And tangent over cotangent cancels. So now I've got tangent over tangent is 1 and cosecant x. And I might say, hey, wait a minute. What if we just move that to the top? I'm always trying to get rid of the fractions. That could just be sine of x. And I'm done. There's my first ones. Okay, so like, there could have been different things. You could have got different results that they broke into, but these were the choices we got. Okay, 5-2. This is the sum and difference of two angles. And on the test, I kind of help give you a little reminder of what you're doing. So remember these rules, and here's some for tangent. So I'm thinking, this plus this. Who's got the plus? It's the first one, sine plus. And it says sine of the first one, cosine of the second one, alpha and beta. So just follow this format. So I'm thinking this is alpha and this is beta. And so the rule says to write the sine of the first one, which instead of alpha is pi, times the cosine of the second one, which is just theta, is a mystery. And then it says plus, and I'm just following my trig sheet, cosine of the first one, pi, then sine of the second one, theta. So then it did the double check because these all look really similar, don't they? Sine, cosine, cosine, sine. Sine, cosine, cosine, sine. Now am I done? And I go, wait a minute. Sine of pi, I know that. I can look that up. Sine of pi is just 0. In fact, I can go sine is the y coordinate, 0. Or some people will just find it a little quicker down here. Pi, 0. So this is 0 times cosine of pi. And then cosine of pi, that's -1. I could look that one up on my sheet. Times sine of theta. And then I'm going, okay, wait a minute. 0 times this is 0, so that's gone. -1 times that is negative sine. And 0 plus, well, I don't even need 0. So this is my answer. So this is the same thing as negative sine of an angle. Okay, so if you did 180 degrees plus an angle, it's the same as just doing the negative of the angle. It's kind of cool because I could check that out. If I pick some angle like 60 degrees and I added pi or 180 to it, that'd be 240. You notice this answer is radical 3 over 2. This answer is negative radical 3 over 2. It's saying if you add 180 degrees to an angle, you get the same answer, it's just negative. That's what's going on. Okay, here's another one. Whoa, there's a lot of stuff going on here. But then I kind of looked, wait a minute. Let's do this guy backwards. Tangent plus tangent, 1 minus tangent, tangent. And once again, I look at my sheet here, and I'm kind of going, that looks like this one, tangent plus tangent, 1 minus tangent, tangent. That's this, alpha plus beta. Okay, he's got the plus. So I'm going to zoom back out for you. So I could just say, this was alpha and this is beta. So let's just rewrite this thing. This must have been tangent of 5 plus 25 degrees. And of course, since these guys are together, they're inside, I could just call that tangent of 30 degrees. And so this whole crazy thing is the same as tangent of 30. I could even look that up if somebody says, could you please look up tangent of 30? I could look it up, or maybe they just want me to stop. I could say, hey, that's radical 3 over 3. And I just look that guy up. Okay, let's go to section 5.3. You can pause the video and try these again. Okay, so now we're going to 5.3. We're going to move this up a little bit. The trick on this one, I just gave you the double angles. In this section, there was all these other ones like half angles. But the thing is, they give me some clues. Make a sketch. What's sine of 2 theta or cosine of 2 theta? What's double this? You can't just double the answer. It doesn't work that way. You have to draw it. So it says quadrant 3, 1, 2, 3. So we're over here. So I'm supposed to draw my triangle over here. I always go from the center, outward, back to the x-axis. Remember, it's kind of like if you were making that butterfly. It's kind of like these always come out of the center. But this is the one I want to use. I don't want to use those other ones. So get rid of those depending on which quadrant I give you. It's important to be in the right quadrant. The angle is always in the center down here because remember, like we go around the wheel. So this is kind of like our reference angle. So we fill in the information they give me. They give me this here. So cosine, I go cosine is the adjacent. So here's the angle, adjacent, -5 over the hypotenuse. This is like x, this is hypotenuse. Yeah, back makes sense. Negative is the back direction because this is positive and negative. It's like graph paper. And then I have to do the Pythagorean theorem. And of course, this is my mystery. And I could do a little 5 squared plus something squared is 13 squared on my scratch paper. I know there's a negative, but when I square the negative, it's still positive. 169. I subtract 144, take the square root, and I get 12. Oh, wait, plus or minus 12. Which is it? Remember, you do this. What do you think? It's down. If it's down, this must be -12 because it's graph paper, back and down. So that's why it's important to be in the right quadrant. So now it wants to know what's sine of 2 theta. So I go and get my rule. A lot of people memorize this one, sine of 2 theta, 2 sine cosine. So we're going to fill this in. We're going to go sine of 2 theta is 2 times the sine of theta times the cosine of theta. So it's 2, and we look these guys up on our chart. Sine is the opposite over hypotenuse. So I'll put in -12/13. Cosine is the adjacent over the hypotenuse, -5/13. And then we'll multiply. Okay, the 2 is like on the top. Don't use it twice. 2 times 12 times 5 is negative times negative is positive, 60, that's 120. And the bottom, 13 times 13, 169. And that's your cosine, or sine, sorry. And let's do the cosine. So cosine of 2 theta. And so I use my sheet to look, and then I do have choices. You can use any one of these. Most people just grab the first one, but you could do this or this. It's really, they all work. It's kind of cool. It's like doing the identities. You could do some proofs and turn this into that. If we were in class, and we would actually figure out how did they come up with that. And it's kind of like they took this and rearranged it to get this. Okay, so let's do the cosine of 2 theta, which is the one that says cosine squared theta minus sine squared theta. I'll put in the cosine and the sine. The cosine is once again the adjacent. I can even just peek right there. -5/13. Sine is the opposite. -12/13. When I square a negative, it turns positive. Go up a little bit. So it's 25/169 because we're squaring both of these. They both get squared. Subtract. Don't cancel this out. PEMDAS, do exponents, then subtract. Remember, square and square, then subtract. Squaring this turns positive. Now it's this, subtract that. So you got to do the exponent, then subtract. And I'm going to go 25 minus 144. I get, that's a little hard to do. Maybe I should even use a calculator. That is -119/169. And there's my answers. If I want to do tangent, I could do even more.